cis-trans isomerism in square planar complexes. Square planar complexes are the complexes with a coordination number that is equal to 4. This means there are 4 dative bonds surrounding the central metal ion. So the overall shape or geometry of this complex is roughly a square planar, or that is equal to the square. This type of complexes, square planar complexes, show cis-trans isomerism or geometric isomerism. So let's see when they will show the cis-trans or the geometric isomerism. What are the main cases? First of all, I'm going to make the 2 categories. Number 1, there is the possibility of 2 type of ligands. Number 1, they may be monodentate ligands, and there may be bidentate ligands. Monodentate ligands and the bidentate ligands. Now come towards the first case, monodentate ligands. What are the basic rules for the monodentate ligands? For monodentate ligands, there are 2 basic prerequisite, you can say, basic rule. Number 1, there must be 2 or more different ligands should be there. 2 or more different, 2 different, 3 different, 4 different ligands must be there. The second prerequisite is there must be no 3 similar ligands. There must not be 3 similar ligands, right? So the first rule is there must be 2 or more than 2 different ligands. And the second criteria is there must be no 3 similar ligands. So in such cases, if there are monodentate ligands, then the square planar geometry will show cis-trans isomerism. For example, I have the case. The first case, there must be 2 different type of ligands. There must be 2 or more different type of ligands. But if I have A, and B, there are 2 type of ligands, A type and B type. A are 3, B is 1. There are 2 different ligands. But the second rule, here the second postulate will rule out. There must not be 3 similar ligands. So complexes having 3 same and 1 different ligand will not show any sort of cis-trans isomerism. They will not show cis-trans isomerism. So there must be, number 1, at least 2 type. Number 2, no 3 similar ligand must be there. So the second case, that is the possible case, A2, B2 ligands. For example, A2, B2. Let's suppose A, and this is the B and B. Yes. Now this complex that is having 2 type of ligands, and those are 2:2. So this complex may exhibit cis-trans isomerism. At the moment, this diagram, this complex which contains 2A at adjacent position and 2B at adjacent position, this complex is basically showing cis isomerism. Its nature of isomerism is cis. How? There is 90-degree bond angle between the similar ligands or similar donor atoms, right? Similarly, another molecule can be drawn that show different arrangement of the ligands. It will be B, B, and A, A. So in this case, in this shape, basically, there are two similar ligands. Those are lying at 180 degree to each. Same is the case with the B ligands, second type of ligands. Those are also present at 180 degree. So this case is the trans case. This complex has the isomerism that is known as trans isomerism, or it is a trans isomer, and this one is the cis isomer. Now come toward the next possibility. If there are, the next possibility is, if there are A, B, and C, let's suppose A2, B1, C1. There are three different ligands or three different donor atoms, you can say as well. What should be the nature of a cis trans isomerism? A, B, and this is the C. So yes, this molecule can also exhibit cis trans isomerism. There are basically three types of ligands. Two are similar ligands, AA, and two are the other different ligands. Total, there are three types of ligands. So once again, similar ligands are lying at 90 degree. So this complex is cis complex with respect to A ligands, right? In this case, the trans complex will be, in this case, A will be in front of each other. Let's suppose A, and here is B, and here is C. So the similar ligand are on opposite sides. Similar donor atoms are on opposite side. So this complex is trans complex. This is trans complex. The next possibility is, if there are all different ligands, A, B, C, and D, there are four different ligands, then what is the possibility of cis trans isomerism or the geometric isomerism? A, B, C, D. So there are all four different ligands. In this case, yes, there is the possibility of cis trans isomerism. As I have told you, there must be two or more than two different ligands. And there must be no three similar ligands. So this is the one molecule that I have wrote over here. What is the second is isomer? It will look like, now in this case there is no simply cis and no simply trans. We are just going to change the different position of their these ligands, and we are going to make the different structures. So the first case is, I'm going to localize this A position. You can localize this A, don't change the position of A, and rest of the position of the ligand I'm going to change to make the other possible different structures. Here is A, and now I'm switching B and C. B and C. I'm placing B over here and C over here basically, and D over here. So these two isomers are not similar. These two complexes are not similar complexes. They are different. In let's suppose this is the complex number 1. This is complex number 2. In one complex, A is in front of C. In second complex, there is A is in front of B. Third possibility in this case will be A, once again, A. Now I'm going to switch C and D. C and D from the first complex. So I'm reporting D over here and C over here and B over here. And I'm going to say it the third one. This is the third complex. So this is different from all above both complexes. In this case, A is in front of D. So there is a possibility of three isomers. No one simply cis, no one is simply trans, but there are three different possible structures. This is all about, in case of monodentate ligands, different square planar complexes can show the isomerism, can show cis trans isomerism, and here are all possibilities. Now come towards the case of bidentate ligands. In case of bidentate ligands, there are basically two prerequisites or two major postulates. Number one, bidentate ligands make their dative bonds at 90-degree bond angle. Usually, bidentate ligands contain carbon that is less than number 6. They cannot make the dative bond at 180 degree. So one thing that you must keep in your mind that bidentate ligands, usually normal bidentate ligand, those are having carbons, 7 carbon or 6 carbons, they make bond angles, they make two bonds at 90 degree. The second prerequisite or the second postulate is, the basic thing is donor atoms are groups in bidentate ligands. If the donor atoms are the donor group in bidentate ligands, they are different. If these donor atoms are different, then there is the possibility of, yes, your complex will show cis trans isomerism. If these donor atoms are same, if donor atoms are the donor groups are same, then possibility of cis molecule only. Cis only. These are the basic possibilities you can say. First of all, bidentate ligands make the dative bond at 90 degree. For example, I'm going to draw over here. Here is a bidentate ligand, ethylene diamine. NH2 is a donor group, CH2, CH2, and this is the second NH2. So these two NH2 groups are making dative bonds to the central metal line. In this case, donor atoms are similar. If there is only one bidentate ligand or there are two bidentate ligands, the basic point is if they are having same donor atom, then there is only possibility of the isomerism is cis. It may be cis in some cases. It may not be cis. This is also a possibility that it may not be cis. Let's see, I'm going to draw in detail over here. For example, here's a complex with one bidentate, and two monodentate ligands over here. One bidentate, once again, NH2, carbon, carbon, and NH2. Let's suppose two bidentate ligand, one is Cl and other one may be OH ligand. So this is once again a square planar complex having two different type of ligands. One is bidentate ligand and other two are monodentate ligands. So in this case, there is only one possibility. Only one possible arrangement is there, that is this one. So this molecule can be cis only. There is no possibility of cis trans pair in this case. Now come towards the two bidentate ligands. Let's suppose there are two bidentate ligands. Two bidentate ligands. If two bidentate ligands are there, let's see what are the possible options. Once again, I'm writing NH2, carbon CH2, CH2, NH2, and similarly NH2, CH2, CH2, and NH2. So in this complex, donor atoms are donor group. All four donor atoms are same. Donor groups are same. In this case, this complex is incapable to show cis-trans isomerism. So no cis, no trans. In this case, this molecule will not exhibit any sort of cis-trans isomerism. If two bidentate ligands and they are with different donor atoms, then let's see over here once again NH2, CH2, CH2, NH2. And I'm writing another ligand over here, a bidentate ligand having oxygen as the donor atom. So now there are two different bidentate ligands. But once again, each ligand having the same donor atoms. So there is a possibility now this complex may exhibit cis only, but no other possible arrangement is there. So this complex will show cis structure only, cis isomer only. The third possibility in case of bidentate ligand, it was the first possibility, no cis, no trans. It was the second possibility, cis only. And I'm going to draw the third possibility in case of all or both bidentate ligands. I'm writing now bidentate ligands with two different atoms are donor groups. Now, oxygen, CH2, CH2, and here NH2. So, one bidentate ligand or each bidentate ligand is showing different donor atoms. Same is the case over here. I'm placing the similar bidentate ligand over here. And NH2. So this complex may show cis-trans isomerism. In this case, look at the donor groups or donor atom. Two oxygen atoms are at 90 degree to each. So this is the cis complex. This complex is cis with respect to oxygen donor atoms. This complex is cis with respect to nitrogen donor atom. Now let's see how this complex show trans isomerism. I'm basically switching the donor atom of one bidentate ligand. Here is oxygen. Here is again a amino group. And now come towards the second one. This complex, now I'm writing oxygen over here and NH2 group over here. So, in this complex, two similar atoms, two similar donor atoms, two similar nitrogen atom, oxygen atom are lying 180 to each other. Same is the case with the nitrogen atom, 180 to each other. So this complex is basically trans complex. Thank you.